Real images of what NASA discovered on Jupiter's hellish moon, Io. Something happened in January of 1610. A smart guy called Galileo Galilei was pointing his telescope at the sky. More precisely, he was trying to point it towards Jupiter. He knew exactly how to do it in order to observe it: the day, the time, the setup. The only thing he didn't know was he was going to discover something special. We are talking about the discovery of Jupiter's moons. Just like an explorer finds new lands after much navigating, Galileo found 4 objects orbiting around the giant gaseous planet. Today we call them Galilean moons, and they are Io, Europa, Ganymede, and Callisto. To be fair, Jupiter is actually something like 80 moons orbiting around it. It is like the king of the moons in our solar system, but the most known are for sure Io, Europa, Ganymede, and Callisto. Just imagine it. It's 1610, and you point your telescope to the sky and find the first evidence of moons besides the Earth's moon, and they are orbiting around another planet. What would you do if you were Galileo? Do you think you could believe your eyes? I think I would have started to cry. In this video, we are going to talk about Jupiter's moon, Io, the probes that visited it, and other amazing things, such as the features of its atmosphere and volcanoes. Keep watching. Since Galileo's discovery, we understood a lot of things about Io. We got to know it better, and now we think we have a very good vision of it. First of all, Io was not Io before. It was just known as Jupiter First, or the first satellite of Jupiter. But then Io was adopted. Do you know who gave the name to it? It was a famous astronomer, Simon Marius. In 1614, he published his work Mundus Iovialis, describing the planet Jupiter and its moons. In his work, he claims to have discovered the planet's 4 major moons a month before Galileo. Because of Galileo's stature in the scientific community, for nearly 300 years, Marius's reputation was tainted by Galileo's accusations of plagiarism. However, a jury in the Netherlands in 1903 examined the evidence extensively and ruled in favor of Marius's independent discoveries. Regardless of priority, the mythological names by which these satellites are known today, Io, Europa, Ganymede, and Callisto, are those given them by Marius. He wrote, which is Latin for Io, Europa, the boy Ganymede, and Callisto, greatly pleased, lustful Jupiter. In Greek mythology, Io is the daughter of Anachus, the river god of Argus, and the Oceanid Malia. As of today, we know that Io orbits Jupiter at a distance of 421,700 kilometers from Jupiter's center and 350,000 kilometers from its cloud tops. It is the innermost of the Galilean satellites of Jupiter. Including Jupiter's inner satellites, Io is the 5th moon out from Jupiter. It takes Io about 42.5 hours to complete one orbit around Jupiter. Io orbits around Jupiter and shows always the same face, as our moon does with the Earth. Surrounding Io, at a distance of up to 6 Io radii from its surface, is a cloud of neutral sulfur, oxygen, sodium, and potassium atoms. These particles originate in Io's upper atmosphere, and we will see how. However, for the next 2.5 centuries after Galileo's discovery, Io remained an unresolved 5th magnitude point of light in an astronomer's telescope, meaning that we could not see its features at all because our technology was not that good yet. In the 19th century, things changed. Technology in those years allowed astronomers to resolve, that is, see as distinct objects, large-scale surface features on Io. Then, with the advent of spectroscopy, scientists found that Io's surface was devoid of water ice. This seemed weird because it was the only Galilean satellite to lack water. The same type of observations was also suggesting that Io's surface is largely dominated by sodium salts and sulfur. But things really got interesting when we decided to send spacecraft on their way to Io. In doing this, we took photos. These pictures are now stuck in our minds, and every time we see one of them, we could not believe that those are pictures of the same moon that Galileo saw for the first time in January of 1610. The first ever spacecraft to pass by Io were the Pioneer 10 and 11 probes. It was a cold December 1973 here on Earth. With the help of radio tracking technology, Pioneer helped us to estimate the moon's mass, which, along with the best available information of its size, suggested the composition of mainly silicate rock rather than water ice. Then in 1977, NASA decided to send 2 probes to visit Pluto. Those were the Voyager probes. The journey would have been long because of the long distance to cover in order to reach it. When the twin probes, Voyager 1 and Voyager 2, passed by Io in 1979, their more advanced imaging system allowed for far more detailed images. It was March 1979. Voyager 1 flew past Io at a distance of about 20,000 kilometers. Very close. The precious images taken showed a multicolored landscape devoid of impact craters. It was such a strange surface. The highest resolution images showed Io as a relatively young object, with mountains taller than Mount Everest and features resembling volcanic lava flows. Navigation engineer Linda A. Morabito noticed a plume emanating from the surface in one of the images. Further analysis showed 9 such plumes scattered across the surface, and that was the final evidence for volcanic activity on the moon. This was actually a confirmation for a theory that has been proposed before the Voyager mission took place. Astrophysicist Stan Peele calculated that Io's interior must experience something called tidal heating. This process on Io is caused by an orbital resonance with Europa and Ganymede. Such heating is dependent on Io's distance from Jupiter, its orbital eccentricity, the composition of its interior, and its physical state. The tidal forces experienced by Io are about 20,000 times stronger than the tidal forces Earth experiences due to the Moon. The friction or tidal dissipation produced in Io's interior due to this varying tidal pull, which, without the resonant orbit, would have gone into circularizing Io's orbit instead, creates significant tidal heating within Io's interior, melting a significant amount of Io's mantle and core. The huge amount of energy produced is released in the form of volcanic activity, generating the observed heat flow. Other moons in the solar system are also tidally heated, and they too may generate additional heat through the friction of subsurface magma or water oceans. This ability to generate heat in a subsurface ocean increases the chance of life on bodies like Europa. When Voyager 2 passed by Io in July of 1979, it took some pictures as well. When scientists compared images taken by the 2 spacecraft, they noticed that several surface changes had occurred in the foremounts between the encounters. This makes Io one of the most hellish moons of our solar system. Finally, in 1995, the Galileo spacecraft arrived at Jupiter. The Galileo mission was entirely dedicated to the study of Jupiter and its moons. Ladies and gentlemen, prepare yourself because you are going to take a look at the most breathtaking pictures we have of Io. Here they are. Despite the lack of close-up imaging and mechanical problems that greatly restricted the amount of data returned, several significant discoveries were made during Galileo's primary mission. For example, we observed the major eruption at Pilin Patera volcano and confirmed that volcanic eruptions are composed of silicate magmas with magnesium-rich compositions. Another important revelation we had from Galileo was that Io doesn't own a magnetic field. But the game was not over. After some years, another interplanetary space probe was launched by NASA. It lifted off on January 2006. Its name was New Horizon, and it was the fastest man-made object ever launched from Earth. New Horizon again was meant for Pluto, but of course, if you happen to pass near to Jupiter, you won't miss your chance to take some beautiful pictures of it and its moons. It made its closest approach on February 28, 2007. The Jupiter flyby provided a gravity assist that increased New Horizon's speed. In doing this, we gained more data about the planet's atmosphere, moon, and magnetosphere. New Horizons also captured images of a volcano near Guru Patera in the early stages of an eruption, and several volcanic eruptions have occurred since Galileo. Here is a Jupiter and Io montage taken by New Horizon. Instead, here are shown changes on Io's surface. And we also have a plume fall. The last important spacecraft that gifted our eyes with beautiful pictures of Jupiter and its moons was the Juno spacecraft. It was primarily aimed at improving our understanding of Jupiter's interior, aurora, and polar atmosphere, and in order to do so, it has a highly inclined orbit that helped better characterize Jupiter's polar regions. Juno was launched in 2011 and reached its orbit around Jupiter in 2016. During several orbits, it has observed Io from a distance using JunoCam, a wide-angle visible light camera to look for volcanic plumes. Here's a visible domain image of Io from JunoCam, showing a volcanic plume illuminated beyond the terminator of Io. The image was taken on December 21, 2018, during the 17th flyby of Jupiter by Juno. While the new Juno images were taken a lot farther away from Io than the previous ones, there is still a lot of information that scientists can obtain from them. For instance, they can provide new insights into how Jupiter interacts with its 5 moons, causing phenomena such as Io's volcanic activity or the freezing of the moon's atmosphere during an eclipse. Even though Io is very small, its gravitational interaction with Jupiter drives the moon's volcanoes, which produce high umbrella-like plumes of sulfur dioxide gas and extensive lava fields. That stretching causes friction and intense heat in Io's interior, sparking massive eruptions across its surface. Juno was the last mission that took pictures of Io. What about future missions? Before finding out the answer to this question, be sure to like or dislike the video. Plus, be sure to subscribe to the channel by clicking the bell so that you don't miss any of our weekly videos. Future missions such as JUICE, which stands for Jupiter Icy Moon Explorer, could help us better understand the wonders of Jupiter's moons. JUICE is an ESA mission to the Jovian system and is intended to end up in Ganymede orbit. It is scheduled for launch in 2022 with an arrival planned for July of 2031. This mission will use instruments to monitor Io's volcanic activity. Another amazing mission will be the Europa Clipper-1, a NASA mission to Jupiter focused on Europa. It is scheduled to launch in 2024, and if everything works out well, it will arrive at Jupiter in 2030. That's all for this video. Thanks for watching, everyone. Did you find this content interesting? What do you think about Io? Do you have any questions for us? Let us know in the comments below. See you next time on the channel.